Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on gravitational field from October-November 2021 paper 4 variant 1. In this lesson, we will discuss what is gravitational potential. Actually, in physics, gravitational potential is not defined. Only gravitational potential difference is defined. So, we will discuss how we can define gravitational potential at any given point. We will also discuss how to find the position of neutral point between moon and our planet. At the end of this lesson, we will also discuss how to determine value of gravitational potential at neutral point between our planet and moon. So we're going to discuss some very good points about gravitational field in today's class. For part A, question is asking us to define gravitational potential. But gravitational potential is not defined in physics. What is defined in physics is gravitational potential difference. So in this lesson, first of all, we will understand what is gravitational potential difference, and then we will discuss how we can derive gravitational potential from gravitational potential difference formula. So first of all, let's try to understand what is gravitational potential difference. Imagine that we have 2 points. Let's say we have point A and here we have point B. You can also imagine that this is our planet. So these 2 points are in gravitational field. Now, if we place a unit mass at this point and its velocity, initial velocity is equal to 0, and we move this unit mass from point B to point A, when this reaches at point A, its velocity is again equal to 0. It simply means that in this case there is no change in kinetic energy of unit mass. So the amount of work done, that amount of work done is equal to the potential difference between A and B. We can also write on this one in this form. We can say VA minus VB, mean the potential difference between A and B. This is equal to the amount of work done from B to A per unit mass. So this is how we can define the potential difference between A and B. Now we need to understand how we can define gravitational potential. For that purpose, we have to take our point B at infinity. Now we will say point B is at infinity, and at infinity we can take potential is equal to 0. So infinity is our reference point. So this is our reference point. So this is our reference point, and at infinity V is equal to 0. So we will repeat the same process now. We will take unit mass from point B, means from infinity. So at infinity this mass was at rest. We take this one and move this mass very slowly and take this mass to point A. So this is our point A. So the amount of work done to bring this unit mass from infinity to point A, this is equal to the potential at point A. In this case, again, there is no change in kinetic energy. Now, if we write down VA minus VB, in this case, VB is at infinity. So we can say the work done to bring this unit mass from B, or we can say from infinity to A per unit mass. That amount of work done is equal to the potential at A, because V infinity is equal to 0. So simply we can say in this case VA, this is equal to the amount of work done to bring this mass, or we can say amount of work done per unit mass from infinity to A. This is equal to potential at point A. This is how we can define gravitational potential. But one thing we need to understand is that this is equal to the amount of work done per unit mass to bring mass from infinity to that point without change in kinetic energy of the mass. So this is how we can define gravitational potential. Now let me show you how you can write down your answer. And this is how you can write down your answer. This question has 2 marks. The first mark, if you have mentioned work done per unit mass, you will get 1 mark. And the second mark, if you have mentioned from infinity to that point, you will get second mark. So this question has 2 marks. And these are B marks, so they have to be in your answer. For part B, it is given to us P is a point, as you can see here. P is a point and it is located on the line joining the centers of our planet and moon, where the resultant gravitational field is equal to 0. And it is also also given to us. Point P is at a distance x from the center of our planet. For this question, we need to explain how it is possible for the gravitational field to be zero. Even there are two large masses present nearby, means nearby this point. So we need to understand why value of G is equal to 0, means the resultant gravitational field at this point is equal to 0. So first of all, let's try to understand the gravitational field due to moon. So this is gravitational field due to moon, and this will be pointing to the right. And now if you look at the gravitational field due to earth, so that will be pointing this way. If the resultant gravitational field at this point is equal to 0, that is only possible if GE, this is equal to GM. So then the resultant of these two will be equal to 0 because they are pointing in opposite directions, so they will apply opposite forces on any mass if we place at this point P. And this point P where G is equal to 0 means the net G is equal to 0, or simply you can say where the net force, gravitational force on any mass is equal to 0 on the line joining these two objects. That point is also called neutral point. Neutral point. It means if you place any mass at neutral point, that mass will not experience any gravitational force. And F net is only 0 if the field due to these two objects are equal in magnitude and opposite in direction. So that's all what we need to understand. Now let's try to write down answer for this question. This is how you can write down the answer. So simply you have to mention that gravitational field from our planet and from moon are in opposite directions at that point. That's the reason the resultant field is 0, because fields are equal in magnitudes at this point and they're pointing in opposite direction. So this question has 2 marks. So first mark, if you have mentioned about opposite directions, you will get 1 mark, and the second mark you will get if you have mentioned they are equal in magnitudes at that point. That's the reason the resultant field is 0, and this point is also called neutral point. So P is a neutral point. For the second part, we need to show that x is approximately equal to 3.5 times 10 to 8 meters. We need to find the value of x. But we have already discussed that at neutral point, the value of G due to Earth, this is equal to value of G due to moon. So at P, they have the same magnitude, but they are in opposite directions. If we need to calculate value of G, simply we can plug in. This is Gm, and this is mass of Earth divided by the distance from the center of Earth to this point. And that distance is x squared. So simply we can write down this is x squared. And for value of G due to moon at that point, we can also calculate that will be equal to G capital M, and this is M mass of the moon divided by the distance from the center of the moon to the neutral point. Let's say that distance is y. So simply we can say that distance means this distance is equal to y. So we can write down here this is y squared. Now you can see here G is common, so this is gravitational constant, universal gravitational constant, so simply we can cancel. So we left with mass of our planet divided by x square, and this is equal to mass of moon divided by y square. But y in this case, y simply in this case is equal to 3.84 times 10 to 8 minus x. So simply we can plug in value of y now. So the y is equal to, so this is value of y is equal to 3.84 times 10 to 8 minus x square. Now we need to plug in values. So the mass of Earth is given, so you can see the mass of our planet is given, and this is 5.98 times 10 to 24, and this is divided by x squared. And here we have the mass of the moon, so mass of moon is given. Mass of moon is equal to 7.35 times 10 to 22, and this is divided by 3.84 times 10 to 8 minus x squared. Now simply we have to find out the value of x. So we solve this one for x. You can simply cross multiply. So let me give you some hints. So you can cross multiply this one. So you can multiply here, cross multiply these two, and you can cross multiply this, and then you can solve for x. So the final value of x, if we solve this one for x, our final answer will be, in this case, 3.5 times 10 to 8 meters. So this will be our final answer for this question. And this question has 2 marks. The first mark is if you have included this step in your calculation, means you have equated GE and GM. And the final mark is answer mark. If you have got the right answer, you will get second mark. For the last part, question is asking us to calculate gravitational potential at point P, means the value of potential at this point, at this neutral point. We have to find out what is value of gravitational potential. If we need to find the gravitational potential at point P, so simply I will write down, let's say Vp. So that Vp will be equal to the potential due to our planet at that point plus potential due to moon at that point. So this is the main concept we need to understand. And now the next thing we need to understand, how we can find the potential due to our planet at this point. That will be equal to negative g mass of our planet divided by the distance from the center of our planet to that point, and that one is equal to x, plus potential due to moon at that point, that will be equal to negative g, capital G, and times mass of moon divided by distance from the center of moon to that point. As I mentioned before, let's say this distance is equal to y. So this will be divided by y. In this equation, for example, we can take negative g, we can take common. If we take common, then we simply left with this is mass of our earth divided by x, plus we can say this is the mass of the moon divided by y. Now simply we need to plug in values and we can find out value of potential at this point. So let me highlight one point. Let's say we take this is our planet, and here let's say this point is infinity. At infinity we take potential is equal to 0. So anywhere from the center to this point, potential is always negative because this is the maximum value of V we have. So anywhere here between planet and infinity, V is negative. So that's the reason we are using the negative sign here, because potential between our planet and infinity is negative, because the maximum value of potential is at infinity and that is equal to 0. So anywhere here it is negative. So that's the reason we are using negative sign here. Now we need to understand x we have already found. So let me write down values of x. X we have found that was equal to 3.5 times 10 to 8. And y, this will be equal to 3.84 times 10 to 8 minus x. Now you can write down the value of x. So we can say this is 10 to 8 minus x. Value of x is 3.5 times 10 to 8. So from here we can find out value of y, that will be equal to 0.38 times 10 to 8. So this is value of y. So you can see this is value of y. So we have found out value of y, we have value of x, we have mass of moon, we have mass of our planet. Now simply we need to plug in these values here. So value of g is 6.67 times 10 to negative 11 times the mass of earth, that is 5.98 times 10 to 24, and this is divided by x, and x is equal to 3.5 times 10 to 8 minus we have the mass of the moon, and mass of the moon is 7.35 times 10 to 22 divided by the value of y, and value of y is 0.38 times 10 to 8. Now simply we need to solve this one, we need to calculate. If we do calculation, in this case our final answer will be negative 1.3 times 10 to 6, and this is joules per kg. So this is joules per kg. So this is how we need to answer this question, and this question has 3 marks. The first mark is if you have written for the moon, for example, we have written what is the gravitational potential of the moon. So if you have written this formula and you have plugged in values, you will get 1 mark, and this is C mark. And the second C mark you will get if you have written moon and our planet gravitational potential, means you have done this step. If you have done this step, you will get second C mark. So this is second C mark. And the third mark is the answer mark. If you have got the right answer, you will get third mark, and this is A mark. This is how marks will be awarded for this question. I hope it is clear to you. If you have any questions about calculations or any other question, just leave your questions in comments section. That's all for this video.